Hi, welcome to section 8.2, set operations and compound inequalities. Hopefully by the end of this, you all will be able to find the union or intersection of two sets, and you will be able to solve compound inequalities. So let's talk about intersections first. So for any two sets A and B, the intersection of A and B, it has this symbol that looks kind of like an upside down U. So that's A intersect with B. It's like a little bridge. Is defined as A intersect B is an element of A and it's an element of B. So if you think about a Venn diagram where you have this set A with lots of things in it and set B with a lot of things in it, and there are some things that they have in common, the intersection is just the things that they have in common. It's that blue part that I shaded in the middle. Okay? So example 1, we're just going to deal with sets of numbers. So a set is kind of like a box of numbers put into it. Okay? So in example A, I've got set A, which has 3, 4, 5, and 6 in it. And I've got set B, which contains 5, 6, and 7. So if I want to do that intersection, A intersect B, I'm looking at what they have in common. Okay, so what do they both have? Well, they both have a 5, and they both have a 6. So that's the intersection, is 5 and 6. That's what they both have. All right. Next up, let's do those and inequalities. This is the intersection with inequalities. So these are compound inequalities. So you're going to get 2 of them, and they're joined by the word and. That's your key word there, that it's an intersection inequality. So the 2 that I gave you, let's see, is x plus 3 is less than 1, and x minus 4 is greater than negative 12. So what you do with compound inequalities is we're going to solve each one separately, and then we're going to graph them both, and then we're going to find that intersection. Okay? So if I want to solve the first one, I would just subtract 3 from both sides. So I'll have x is less than negative 2. And if I solve the other one, I'm going to add 4 to both sides. So x is greater than negative 8. Then what I'm going to do is I'm going to graph both of those things on a number line. So here's 0, there's negative 2, negative 3, 4, 5, 6, 7, and there is negative 8. Alright, so if I'm just graphing x is less than negative 2, I would have a parenthesis at negative 2, and I'd go to the left. Okay. If I'm just graphing x is greater than negative 8, I would have a parenthesis at negative 8, and I would go to the right. Okay, so you see how I'm graphing those things kind of on top of each other? For those and inequalities, you're looking at the intersection. You're looking at where they overlap each other. And so where they overlap is right here. If you notice both lines on top of each other, this is the intersection. So I'm going to shade that so I know that that's my solution for the compound inequality. Okay, and I can write that in interval notation. So in interval notation, this intersection area, the left side of it starts at negative 8. And on the right side, it ends at negative 2. We'll have parentheses on both just because we had a less than and a greater than. There were no or equal to symbols in there. So that's the interval notation for that intersection. Okay, let's try another one. Example 3. The 2 that I have for you, I have x plus 2 is greater than 3, and, so there's my keyword that it's an intersection, 2x plus 1 is less than negative 3. So I'm just going to solve each one separately. My first inequality, I'm going to subtract 2 from both sides. So now I have x is greater than 1. On my second one, I'll subtract 1 from both sides. So I have 2x is less than negative 4. And then I'll divide both sides by 2. So now I have x is less than negative 2. Okay, so those are my 2 answers that I have. I have x is greater than 1 and x is less than negative 2. Okay, so if I graph both of those on the number line, let's see what they look like. So x is greater than 1. Here's 0, there's 1. I'll have a parenthesis at 1. I'm going to go to the right for that graph. X is less than negative 2, so there's negative 1, and there's negative 2. X is less than negative 2 would have a parenthesis because it's just less than, and it's going to go to the left. Okay, now that I've graphed both of them, I'm going to do the and part of it. Okay, so the and makes me look at the intersection or the overlap. What I notice in my graph is that those two graphs don't overlap at all. They never intersect with each other. And so there's nothing that will satisfy both of those things at the same time. And so this one is actually no solution because there's nothing that does both of them at the same time. There's no overlap or no intersection. Okay. Now it's your turn. You guys get to try one and show me how much you've learned.